Hello everyone, welcome back to the course Data Structures. In today's class, we are going to discuss about stack using arrays. Let me share the screen to discuss about today's concept. Today we are going to discuss about stack using arrays. By the end of this lecture, you can able to know how to create and implement stack operations using arrays. Coming to stack ADT, we are going to discuss about and how you are going to implement stack. We already know that what is stack ADT. ADT is nothing but abstract data type. Abstract data type is going to represent about data and operations. And while coming to implement this stack using arrays, the data which you required is top, and the operations which are going to perform on stack are push, pop, peek, and display, and is full and is empty. These are all the operations we can able to implement on stack using arrays. And while coming to push, what is the use of this push operation in stack? We can insert an element into the stack. Push is nothing but insert an element into the stack. Pop is nothing but removes an element from the stack. And peek is representing, it is going to print the top element from the stack. And display represents, it is going to print the contents of the stack. And is full, this is a function which it is going to check whether the stack is full or not. And is empty, to check whether the stack is empty or not. These are all the operations that comes under stack editing. Coming to stack implementation, here a stack can be implemented in two ways. One is using stack using arrays and another one is stack using linked list. Now we are going to see about stack using arrays. Coming to stack using arrays, we all know that array is nothing but it is a collection of similar data elements. But in stack, we are going to use the operations of push and pop are going to be performed only at one end. That is nothing but the top. And let us assume the procedure how we are going to push the elements onto the stack. And the name of the stack which you are going to give is stack itself. And the size here we are going to consider it as 5. And top is representing with -1. That is initialize it to -1. Initialize it to -1 is representing that the stack is empty. In the step 1, just you observe, just similarly, this is looking similarly like an array, but there we have represented linearly, that is horizontally, but here we are going to represent the stack in the form of vertical. And here, these are the indexes which it is going to represent, and top equal to -1 represents the uh, stack is empty. And coming to step 2. Now I want to push some element onto the top of the stack. In that particular case, I am going to push A. First, you need to read that particular element A. Then that is the top has to be incremented, and then we can able to push the element onto the top of the stack. When top gets incremented, top becomes 0. Next, coming to the next step, if I want to push B, first you need to read the element of B, and then you are going to push, that is increment the top element, top will be incremented to 1. Now we can able to push the element onto the top of the stack. In the similar way, push C, in this particular case, you are going to increment the top and you are going to push the element onto the top of the stack. Next, step 5, you are going to push one more element, that is D. First increment the top, then push the element onto the stack. Next, I want to push E. First read E, increment top and push the element onto the top of the stack. And if I want to push one more element, that is F, in this particular case, you don't find the space for inserting F into the stack. In this case, top will be incremented and it will be checking with the condition top is greater than or equal to size -1. Actually, I have taken the size as 5. 5 minus 1 means it can store up to n minus 1 is, sorry, that is size minus 1 is nothing but up to 4. It will be, it can be stored. But here, if I am going to give one more element, it leads to an error flow condition called overflow. This will be happen when I'm going to insert an element if the condition is not satisfied with the top. Now, how to implement this? Just see the code, how we are going to write the code for push operation. Here, if top is greater than or equal to size minus 1, then stack overflow, that is the error it is going to show. Else, what you need to do? You need to read the element that may be of a character or an integer value and increment the top, and that is going to be placed on top of the stack. In this way, we can write the code for push operation. And what is the procedure for pop operation? Yes, you see, consider the same example which we have taken for the push. Now, here we have 5 elements, that is A, B, C, D, and E, and top is pointing to the top element of the stack. Now, I want to pop the element E from the stack. In that particular case, first it is going to remove the element E and top will be decremented. Now top becomes 3. In the similar way, if I want to pop the element D, in that particular case, first remove the element and I am going to decrement the top element. And in the next case, step 4, if I want to pop the element C, remove the element and the top will be decremented to 1. And in the next case, if I want to remove B, in that particular case, remove B and decrement top to 0. And in the next case, if I want to remove A also, then remove A and top will be decremented and top becomes again minus 1. In this particular case, if I am going to reach top equal to minus 1 means you don't find any elements in the stack. You are unable to remove any elements from the stack. Now the stack becomes empty. In this particular case, if I want to remove an element from the stack, it leads to an underflow. Now, stack using arrays by using pop operation. If top equal to minus 1, then you are going to print stack underflow. That is an error. Else, you are going to take the top of the element from the stack and that will be placed in X, and then you are going to decrement the top value. In a similar way, we can have to print the top element from the stack. That means by using the peek operation. Just use that function peekoff and use the printf statement to print the element from the stack. And how we are going to display the elements by using this means here you already have some 5 elements into the stack. Top is pointing to the first element in the stack. Now you are going to place the element E onto the stack. Now decrement top will be decremented and it is going to point to the next element. In that particular case, you are going to place D onto the array. And the next one, top should be decremented and you are going to, it is going to place top equal to 2 and we are going, it is pointing to C, then we are going to print that particular element. And top will be decremented. Sorry, this is top is going to be decremented. This should be 1. This should be 1, right? Now, whatever the element it is going to show, that is going to be placed in the stack. Next, the last element we have, A. Top will be again decremented and it is going to pointing to A. A is going to be placed and it is going to be printed. And if you are going to see the code for this, first we need to print the statement as stack contents or this one, and we need to initialize I equal to top and I greater than or equal to 0, and I should be decremented until it reaches the end of the stack, and in between that we are going to print I values. That means it is going to print the elements in this order E, D, C, A, B. In the order it is going to print is E, D, C, B, and E. In this order we can print the elements of the stack. Thank you for listening.